Okay, so we have this interesting logarithmic equation here. Log to the base 2 of x equals log to the base 3 of x plus 1. So let's see how we solve this equation. So what we are going to do here is we could apply change of base. And the rule for change of base, we have log to the base b of a will be equal to log a base 10 over log b base 10. Take note, log a base 10, log b base 10. Both log a and log b are given an identical base of base 10. That is why it's called change of base. So we are going to apply that logic here. So we are going to do log x base 10 over log 2 base 10, exactly how it's been done here. So here will be log x base 10 over log 2 base 10 equals the same thing here, log x plus 1 base 10 over log 3 base 10, exactly what is being done here too. Log x plus 1 base 10 over log 3 base 10. So, and now we could look at the left hand side, and log 2 base 10 is here as the denominator here. We could multiply the left hand side and right hand side by log 2 base 10. So times log 2 base 10, and the right hand side also times log 2 base 10. Then this cancels out, log 2 base 10 cancels out, you have 1 remaining, and log x base 10 divided by 1 is still log x base 10. So I have log x base 10 equals, this can be over 1. I'll multiply also the numerators here and the denominators. So this times this gives me log x plus 1 base 10 times log 2 base 10, and I have log 3 base 10 times 1 still gives me log 3 base 10. Then I could divide both sides by log x plus 1 base 10. Divide here by log x plus 1 base 10, and also divide the left hand side by log x plus 1 base 10. So divide here by log x plus 1 base 10, and also divide here by log x plus 1 base 10. So this cancels out this. So I'm left with log x base 10, log x base 10 over log x plus 1 base 10, log x plus 1 base 10 equals, then this is left here on the right hand side, log 2 base 10 over log 3 base 10, log 2 base 10 over log 3 base 10. And notice something, if you look at the equation carefully, you notice you have log x here and you have x plus 1. And here you have 2, and down here you have 2 plus 1, 3. Look again, x, and you have x plus 1 down. There you have 2, and you have 2 plus 1, which is 3. It shows that the right hand side and the left hand side are identical. So you have x plus 1. Here you have 2, and you have 2 plus 1, which is 3. Definitely the right hand side and the left hand side are identical. And since they are the same, they are identical, I could equate the numerators. I could just say log x base 10 equals log 2 base 10, or I could equate the denominators, whichever way I'm going to end up getting my value for x. So if I decide to equate the numerators, I'll have log x base 10 equals log 2 base 10. Let's see how that goes. So equating the numerators, log x base 10 equals log 2 base 10. Then moving this one to the left hand side, I have log x base 10. The plus sign becomes minus when it comes over log 2 base 10. Then you have 0 left on the right hand side. Following the law of logarithm, we have log, we are going to divide the numbers because it's subtraction, x over 2 base 10 equals 0. Then of course we know that 10 raised to the power 0 must give me the number here. So x over 2 must also be equal to 10 raised to the power 0. So x over 2 must be equal to 1. Then you can put this over 1 and then you cross multiply. X times 1 is x, 2 times 1 is 2. So definitely x equals 2. Or we could equate the denominators and see if we are going to get 2 also. So log x plus 1 base 10 equals log 3 base 10, whichever way you want. So let's equate them and let's see the magic here. Log x plus 1 base 10 equals log 3 base 10. Then moving this log to the left hand side, we have log x plus 1 base 10 minus log 3 base 10 equals 0. You have 0 left on the right hand side. Then following the laws of logarithm, we can have log base 10, then x plus 1 divided by 3, x plus 1 over 3, because this subtraction, equal to this 0 again, and then 10 raised to the power 0 must give you the number here. So x plus 1 over 3 must give me 10 raised to the power 0. And then x plus 1 over 3 must give me 1. Then I can put this 1 over 1 and then cross multiply. X plus 1 times 1 still gives me x plus 1 equals 3 times 1 gives me 3. Then collecting like terms, I have x equals 3 plus 1 becomes minus 1. And I have x equals 2 also. So equating the numerator or the denominator must give the same value for x. So you have to pick one of them. Either you equate the numerator or you just equate the denominator. You still get the key answer, which is x equals 2. So that's it.